Good Monday morning to all of my HA scientists out there. It's good to see you guys again. Well, kind of see you through through the screen here. Today we are going to finish our final PhET simulation about the skate park, and this will help us to understand how kinetic energy and potential energy, how they relate to each other, how they work together. So, number one, I'm on day 5 slide. Step number 1 says click here to open up the PhET simulation website. And this time we're going to go to the playground. Okay, so we haven't gone there yet, so that's a new button. We're going to click on the playground. So let's do that now. In here. And instead of the intro, I'm going to go to playground. And that sometimes takes a minute to load up, so I already have it waiting for us right here. So this is the playground. And we're going to make a skate park roller coaster here. So I'm going to start by picking up part of the ramp. I'm going to start way up high because one thing I have learned about potential energy is the higher you are, the more potential energy you have. So I'm going to try and start as high as I can. And then I can just move around these red dots here. Notice how moving the red dots will help me make different types of ramps. And then I pull up a second ramp and I just attach it right there and they will automatically link together. Here we go. I'm going to now try to add a hill over here. So it starts to look like our U ramp. But I'm not going to go all the way up. I'm going to connect that again and then make a little hill. Here we go. Go back down. I'm going to add one more, connect it there, one more ramp. There we go. And I'm going to have it slide down there like that. Now, before we play around here with our skateboarder, I'm going to remind you to select each of these white boxes here so that we can see our pie chart, our bar graph over here, and our speedometer pops up right here. You can always adjust the mass and see how that affects things. I'm going to leave mine in the middle. Over here we have friction. This is where thermal energy will come in. For the sake of today, I'm going to put that at none, but I encourage you, try it out and see how it looks different. Here we go. Let's put our skater right here at the top. Now notice if you don't start her at the top, let me pause it first. You can start her at different positions here. Top, middle, bottom, okay? And I think this is kind of interesting to note. If you hit start right there in the middle, she will speed up and slow down, but she won't make it over the first hill. So I'm going to grab the skateboard. We're going to start higher up. And now we can make it all the way over. If I did use friction here, let me start. Notice what happens. Starting at the top here, she starts to slow down more. In fact, restarting. Got her. Alright, so where I started the last time, because of friction, she won't have enough energy to go over that first hill. So I'm going to start higher up even. There we go. And finally she makes it all the way through. But like I said, we're not dealing with friction today, but I thought that's interesting to look at what effects that has. So I turn that to none. Restart. And pause. There we go. Going back to the slideshow. It says now, click the following, create the following ramp so your screen looks like mine. Okay, that's what I kind of did with you. It doesn't have to look exactly like mine, but it does need to have a hill. Notice this hill right here is not quite as high as the one we start with. That's important. If you have this one higher, she'll never make it over. So your skate should be able to travel from the start to the finish without getting stuck. So you might have to adjust the ramp a little bit here and there in order for the skateboarder to make it all the way through without stopping. Then once you've done that, click here to answer some questions. So once you've created your park, it looks similar to mine, you're ready to go to the form and tell me what we've learned here today. Put your first and last name right here for me. And notice how I have four places here I want you to look at. Top of the hill, bottom of the first hill, top of the second hill, hill B we'll call it, and the bottom of hill B over here. Okay, so these are the areas we are going to be looking at. So send the skater to complete the track. Use the bar graphs, the pie chart, the speedometer to describe whether her kinetic energy is high or low, whether her potential energy is high or low, and whether her speed is high and low at each of the following arrows. You should have 3 boxes checked per row. Now, that's important. We're going to look at that. 3 check marks for each row. Pausing the skater at each of the arrows will help you. So try to pause her at different spots. So here we have at the top of the hill, this first arrow. What is her kinetic energy? High or low? Potential energy, high or low? And speed, high or low? Let's go back, and here she is. Grab her at the top. Okay. So here you can kind of see what her potential energy is, what her kinetic energy is, and what her speed is. And so then you can go back and put those answers in. 3 check marks for this row. Then it wants to know what about at the bottom of the hill. So let's see if we can get her to stop right about the bottom. Yeah, that's pretty good. Doesn't have to be exact. So right here, look at her kinetic energy, potential energy, and speed. Go back to the form, and now compared with when she's at the top, down here at the bottom of hill A, what's happened to her kinetic energy, potential energy, and her speed. Okay. Then we're going to do this again. We're going to stop her right here at the top if we can. Let's see if I can do that. Ready? And oh, there you go. Pretty good. Close enough right there near the top. Going back, top of hill B. What about her kinetic energy, her potential energy, and speed compared to what it was like down here at the bottom of hill A? Okay, so what happened to her kinetic energy up here? Is it higher or lower than what it was? Is her potential energy higher or lower than what it was down here? And is her speed faster or slower than what it was down here? And then one more is at the bottom of the hill, so let's try that out. And there she goes. So again, look at kinetic energy, speed, and potential energy. And then you can answer that question right here at the bottom. Then we only have one more question. This one, I'm asking you to write 2 sentences. It says, based on the boxes that you checked above, what have you learned about kinetic and potential energy and speed in regards to building a skate park or roller coaster? Okay, so I really want to know, what do you notice about the changes that happen between kinetic energy and potential energy? Do they go together or are they opposite? Let me know that and explain that to me, please, from what you noticed. Use evidence that you saw, use the information you put up here, and put that into 2 sentences down here for me, okay? Then hit submit. And then the last thing, oops, I skipped ahead there, on day 5 is complete any work from the first 4 days that you may have accidentally missed. So go back, make sure you have everything there. When we come back tomorrow, we're going to talk about our project, building the roller coaster. So this is I'm giving you 3 days to work on this, and we'll talk about that tomorrow. All right, have a good day, be safe, and stay in touch.